The purpose of this video is to go over the steps to solve systems of equations that have three variables. We're going to use the elimination method, and we're from Chapter 3, Section 4 of our Algebra 2 book. The goal here is that you're going to want to manipulate two equations at a time so that you can add them together and one of the variables cancels out, which is the elimination part. So here's some things you might want to remember, okay? In order to solve an equation that only has one variable, you just need one equation, like 4x plus 12. You can just divide both sides by 4, and you can find the answer to the variable. But if you have two variables in an equation, you're going to need two equations in order to eliminate one. So you'll have to add them together and manipulate one in order to do that, which has been done in many of the Algebra 1 classes and also earlier in Algebra 2. In this case, we have three variables, and so you must have three equations in order to solve them. That's the nature of solving for variables. So here's an example problem from a textbook. I've randomly put them in any kind of random order, but I'm going to go ahead and label them as equation 1, equation 2, and equation 3. There's no particular method to this. I would just do this in your notes. Pick one to be 1, pick one to be 2, pick one to be 3. So the goal here is that you want to be able to eliminate one of the variables, and you can choose. So I just look at the equations and say, what seems to make sense here? What's the easiest for me to eliminate? So you're going to choose two of the equations above and add them together so that one of the variables is eliminated. I'm personally going to choose equation 2 and 3. You could have chosen any combination that you wanted to, but what I'm going to do is I'm going to multiply equation 2 by 3, okay, so I'm going to have a 3x minus y plus 4z is equal to 6, and the reason I'm doing this is because I want to be able to eliminate the y. I can see that if I multiply this times 3, then I can take a negative 3y and a positive 3y, and it'll be eliminated. So I'm going to go ahead and write this out. I'm just getting equation 3 ready, okay, or equation 2 ready. Excuse me, I'm getting equation 2 ready so that I can then add it to equation 3. So now I'm going to add it to equation 3 above. So negative x plus 3y plus z is equal to negative 9. So when I add them together, I'm going to get okay. So now I have an equation with only two variables. That's nice. I like that. Okay. Now I need another equation because I can't just solve for one of these variables. I need two equations. So the first step was to choose two equations to add together and manipulate one so you can eliminate a variable. We eliminated y. Now we have to incorporate whatever equation we didn't use before. It has to be used now, and you need to try to eliminate the same variable. So we must eliminate y again. Now up here we use 2 and 3, so we have to use 1 in our next equation. So when I'm looking at equation 1, there's a 4y here. If I multiplied this times 4, then I could add these two together and the y's would be eliminated again. You have to eliminate the same thing. So we're going to use equations 1, and then we're also going to use equation 2, but we're going to multiply equation 2 times 4 in order to eliminate that. So I'm going to go ahead and show that work. So I'm going to take the second equation. Okay. All right, so this is equation 4, and this is equation 2, and I've manipulated it times 4, okay? So I'm going to go ahead and put equation 1 underneath it. All right, I'm going to add them together. This is eliminated. All right, so this comes in handy because now look, I have an equation here with an x and a z, and I have an equation here with an x and a z. So since I have two equations with two variables, I can solve them the way that I did before. So that makes it nice. I'm going to go ahead and give this another number. I'm going to call equation 4. because it's a new one, and this one I'm going to call equation 5 because I've just generated it brand new. So my next step is to take the two new equations with those same two variables and use them the same way you would have normally to eliminate them. So I'm going to use equation 4 and 5 to eliminate the variable. Now I'm going to need to manipulate them because there's not anything that you can just simply add together and something be eliminated. Now when you look at this, there's really not any great easy way to do this. So I'm going to multiply this one times negative 13 and this one times 8 because there's not really a common multiple here. So when I do that, and again I'm doing that so I can eliminate x. I've just chosen x. You could have chosen another one. That's okay. All right. Okay. Now that I've done that, I can add them together. X is eliminated, which is really nice because then I know that if I only have one variable in an equation, I can solve for that variable. So I divide both sides by negative 57, and I get that x, or z, excuse me, is equal to negative 3. Okay, so this is great because I had two equations, and I had two unknowns, and I eliminated one, and so now I've solved for one of my variables. Okay, so once you solve for one variable, you can plug it back into one of those new equations that we made and easily solve for another. So it doesn't really matter which one. You can just pick whatever you want because you know what z is. So whether you put it in here or here, you're going to get the same value for x. So I'm going to decide, I'm just going to use equation 4, just at random. It doesn't really matter. Okay. All right, so this is awesome because now I have two of the three variables already solved. I have the solution for two of them. So once you do that, you take the two variables that you now have a value for and go back to one of the original equations that you started with and plug in two of the variables. So now you've got a situation where you know what x is, you know what z is, and so no matter which equation you use, if it's a true solution, you'll get the same value for r. I'm going to choose equation 3. It doesn't really matter, but you could choose whatever you wanted to. So I'm going to put in 6 in for x, and I'm going to put negative 3 in for z, and I can combine the negative 6 and negative 3 and become negative 9, and I have a 3y. And so when I add 9 to both sides, I get 3y is equal to 0, which means that y must be 0. Now at this point, I have x, y, and z. The proper way to write the solution for this, the final solution, is going to be in coordinate form. And it's going to look like this, x, then y, then z. And so for this, x is 6. Y is 0, and z is negative 3. And this would be your final solution, which means that all three of these systems, these planar systems, this is a plane and the XYZ coordinate, this is a plane and this is a plane. The solution means that this is where they intersect, and these three planes intersect at this point. If you follow these steps each time, you will get the right answer. Again, the first step is just to choose two of the original equations and get rid of a variable. The second step is to do the same thing, but now you have to use the equation that wasn't used before, but you're still getting rid of the same variable. We got rid of y here, so we have to get rid of y here. So we have to use the other equation that wasn't used. Now you have two equations and two unknowns. So you take those new equations Okay, there's two new equations, and you're trying to eliminate one of the two variables that are left. In this case, I chose x. That's fine. You can solve now for one variable. Once you have a variable, you can plug it back into here because it only has two variables. And if you have the answer to one, the other one is just solvable. Now you have two of the solutions. So you go back to one of your original equations. You have two solutions, and you can solve for the very last variable. And you finalize your answer by putting it in the coordinate form. Good luck.